In this video, let's start working on question 4. So let me change colors, by the way. The power for Andy's test with alpha equals to 0.2 and a true population mean of $1,600 is gonna be 0.11, true or false. Now recall, same question, same data, same hypothesis that initially we're testing whether the mean differs from 1700. Let's see graphically what we're looking for. So under the null hypothesis, in the distribution of the balances in dollars has a mean of 1700, we want to know what are gonna be the values where we can reject the hypothesis. So what has to be at least the value on this side, on the right side, and on the left side that's gonna make us reject the hypothesis, that's gonna give us enough evidence to say that the mean differs from 1700, given that the probability of having that result by chance is gonna be 5% over here and 5% on the left side. So alpha equals to 0.10, that is the p-value that we're speaking of, the probability of having these results by chance. Now, how can we calculate these values? Like, these are our question marks. Well, again, since we're dealing with probabilities, we must translate our distribution into the z distribution. So that's what we do right now. We're gonna have over here below the z distribution based on this data like that. Now we know that the mean of the z distribution, this one, is gonna correspond to a z value of 0, because that's the property of the z distribution. It has to have the mean of 0. We're looking for this. How can we convert this number? How can we convert this number into the critical values on the z distribution? What are going to be the critical values on the z distribution? Where when alpha is equal to 0.10, having this tail of 5% corresponds to a z value of 1.645. Again, you can find this in the z distribution, it's given, and the opposite, minus 1.645. In other words, now with these two numbers in mind, we can find out what is going to be the value of the balance in dollars that we're looking for to substitute on this table. So how can we do so? By converting. Since we know that the z value to reject the null hypothesis must be greater than 1.645 on this side or less than minus 1.645 on the left side. So let's do them both at the same time in parallel so we can see how we do it. We're gonna reject h0 if. So reject h0 if, and we have two options. First of all, z must be greater than or equal to 1.645 over here, or z is gonna be less than or equal to minus 1.645. Z is less than or equal to minus 1.645. Now, what z, remember, z is a standardization, so we're gonna take the difference from that sample mean, which we don't know. That's the question mark we're looking for. We're gonna take the difference from this one relative to the population mean, because we want to know how far away is it from 1700 in terms of standard errors. So we take x bar that we're looking for, the sample mean that we're looking for to reject the null hypothesis, minus the population mean under the null hypothesis, which is 1700, divided by the standard error, which is the standard deviation 2833.33, divided by the square root of n, which is the square root of 145. This must be greater than or equal to the critical value, greater than or equal to 1.645. What do? We do a cross multiplication to find out the x bar. So we multiply this entire thing with 1.645, and then we add 1700 to it. So x bar is going to be greater than or equal to 2087.06. So that has to be the value on this side of the distribution. We can write it right ahead so that we have it graphically as well. We're gonna have here 2087.06. Same logic goes here. We're replicating the math. The only thing that changes is the signs. We're gonna have the z value being less than or equal to minus 1.645, so that we can know the value when we can reject the null hypothesis on the left side. So what's that going to be? Same logic, same standardization, the difference between the sample mean and the population mean in terms of standard error. So we do so over here below. What are we gonna have? We're gonna have the following. We're gonna have x bar. We're gonna have x bar minus the population mean under the null 1700 divided by the standard error. Same math. So 2833.33 over square root of 145 less than or equal to minus 1.645, less than or equal to let me put that minus normal, yes, minus 1.645. Do the math. We do the cross multiplication. How? We take this result, multiply it with the cross of minus 1.645, add 1700 to it. This goes there. So the x bar is gonna be less than or equal to 1312.94. So this is the other value that we're gonna put on our distribution. Let's put it straight ahead so we can have the graph and we'll see that it makes sense. So look how this is gonna be. 1312.94 is gonna be over here. 1312.94. So notice, you see this is to the left of 1700, this is higher than 1700 to the right. So graphically it makes sense. We'll stop here in this video. In the next video we're gonna work with these numbers to find out the actual power of the test.